Okay, so let's draw a barrel vault intersection, and then we will basically get the volume generated by that barrel vault. Like you could imagine getting the barrel vault and like flipping it 180, then pouring, I don't know, concrete or something, and then removing the initial intersection, and you've got that volume left. We've got that volume that we need to draw, and then we will cut it with a 30-degree plane and fit the largest sphere that can be tangent to the interior of this volume and to the plane. Okay, sounds good, right? Something different. Okay, so again, let's start with the barrel vault. We need to basically generate that. Actually, let's not go for a 30-degree plane. Let's go for a 22.5-degree plane. So how do you do that? You get a 45-degree angle and you draw its bisector line, right? So the line that goes down the middle. How do you draw the bisector? By basically intersecting two arches on the basically intersecting two arches on the segment which is equally distant from the tip of the angle that you want to draw a bisector of. Okay, you draw those two arches, you intersect them, and then you get the median line, which coincides in this case with the bisector line. Okay, there we go. And if we want to fit the sphere, it's going to be obviously on a vertical starting from the center of the intersection, and then you intersect that with another bisector line starting from the right hand side angle. Okay, and you get that angle by basically you construct that angle from the initial incline line of the plane, and the horizontal line you get from the tip of the barrel vault. Okay, and that's how you fit the sphere. Intersect the vertical and the bisector formed from that angle. And there you go. A bit weird, a bit different. It's going to look a bit better in axonometric because you'll see the actual barrel vault. If you remember, two cylinders intersecting. Okay, there we go. And let's see how this looks like. Okay, a bit of a mistake there. Right, so sometimes I get carried away, with the line drawing, but that's fine. Okay, so there we go. Let me just mark the axes for our reference system. And let's add some dashed lines. Yes, sometimes I skip over the details, and that's bad. There's a little point in the frontal view, little segment there that doesn't look quite right. I should correct that. Right, there we go. Just a bit of a correction. Right, and let's go for the plane of view as well. Let me correct that. So I'm drawing the barrel vault right now. Remember, it's intersecting, but don't forget we are drawing now the object, the volume generated by the vaulting. So it's going to look like a half circle in the frontal and side views, and like a square with diagonals in the planar view. There we go. Let me draw those arches which form the frontal views. And then we will go for the axonometric, and it's going to make a lot more sense. Okay, so this is an isometric of the volume. So basically starting off with drawing a square, which is going to be the base of our intersection, then drawing the half cylinders. If you remember, the the barrel vault intersection from Technical Drawing 101. It's basically two intersecting cylinders, but there's a catch. This time, we won't have a thickness to our barrel vaulting. So it's just going to be the volume generated by the barrel vaulting. Like you could imagine, the barrel vaulting would have a thickness, but it goes above all of this, okay? So like on top of this, but we just need the volume generated, okay? So basically drawing the half cylinders, just like so, fitting everything into a boxy box, and then going for the half cylinder. Yeah, parallel lines all over. There we go. Point over there. If you remember these half ellipses, you need to find the point which would generate the larger arch, right, for your construction, and the point which would generate the smaller arch. There we go. Right, there we go. Just constructing these arches, just drawing all four in one go, all the large ones. Now let's go for the small ones. Again, I'm drawing all four. I don't want to have to change the compass too many times. Okay, very good. Now let's generate the volume. So we need to intersect those 45 degrees. So we got the maximum of our custom ellipse, okay, the 45 degrees, and the minimums. And that will generate 5 points, which, if we connect, we get the ellipse. There we go. And this is going to help us actually generate this volume. You'll see why in a second. So I'm basically going from the top of actually no, let's draw the plane as well. I just copied the height of the plane, and I'm just going to draw the plane cutting this intersection. And I will get the radius of our sphere. Go down from the top of our intersection, then draw the maximum horizontal ellipse that is going to generate our sphere. Hopefully this all makes sense. You know, it's easier to basically do it than it sounds. Okay, so I'm doing the ellipse now, the largest ellipse for our sphere. Again, same thought process as before, using diagonals and constructing these custom arches, just like so. There we go. Yeah, just constructing the custom arches and then constructing the sphere. Right, that was a small mistake of mine. I basically forgot that we need to go one radius down from the middle, right, from the maximum point of our intersection. So we got the maximum, we go down one radius, okay, that we get from the frontal view, and then we draw that custom ellipse. Okay, there we go. Let me just thicken these, just thicken everything. Yeah. So I'm basically thickening the contour right now. The sphere has got dashed lines. There's a couple of edges that are going to have dashed lines as well, one there and one there. And that's our assignment. It's very interesting, it's different, it's a good warm-up for the advanced technical drawing that is about to come. Next.